Hey everyone, so this video is about the conic section of the ellipse, and we are going to talk about specifically how to write the equation of an ellipse, how to identify the foci of an ellipse, and we are going to be graphing ellipses today. So what is an ellipse? An ellipse is a set of all points P in a plane such that the sum of the distances from P to two fixed points Fi and F2 is a constant K. A focus of an ellipse, and you'll hear me say foci, is one of the two fixed points. So you can see we've got points all around, like they're just giving you examples, all around this shape. An ellipse is like an egg shape, an oval shape, kind of like a squished circle. And if you take the sum of those, the distances from P to two fixed points, and these are your two fixed points, it's all going to be the same, a constant K, okay? And so the foci here are really important key features of an ellipse. And so let's talk about some other key features that we're going to be referencing and identifying throughout examples of ellipses. So the major axis is the segment that contains the foci and has its endpoints on the ellipse. So when we look at ellipses, and we can have horizontal ellipses and vertical ellipses, the major axis, and that's what this main point here is your major axis for a horizontal ellipse, and here is your major axis for a vertical ellipse. And that major axis has your foci, and we use the variable c to talk about foci. And so you can see here's your focus, here's a focus, and then here's a focus, and here's a focus. And they're always on the major axis. The center of the ellipse is at the center here. It's the midpoint. And then we have a minor axis, which is perpendicular to the major axis. So you can see if the major axis is the horizontal, your minor axis is the vertical. And if your major axis is the vertical, your minor axis is the horizontal axis. They are perpendicular. And so then we also have these vertices. We have vertices and co-vertices. The vertices of an ellipse are on the major axis. So you can go find your vertices on your major axis, and then you can notice we've got co-vertices on the minor axis. Same thing here, these are vertices, and your minor axis has your co-vertices. And so the co-vertices are on the minor axis, okay? Co-vertices are not major, right? Vertices are major on your major axis. And we also have different variables to identify these key features of our ellipses. So we have our standard equation here, and you can see the main difference between our equations is where A is. So here is A. Get this going, this highlighter, and here is A. And we want to notice that A squared is always the largest denominator. Okay, and that's really what depicts whether we're going to have a horizontal ellipse or a vertical ellipse. And if I have a horizontal ellipse, just like we saw above on that previous page, we have our major axis horizontally because it's falling and your vertices are falling on your major axis. If I have a vertical ellipse, it kind of looks more like an egg shape that way, and your vertices are on your major axis this way, okay? And then for those same reasons, your vertices are plus or minus a comma 0, and so that makes sense because this is when I'm moving left and right, and so I put like a left and right, and 0 comma plus or minus a makes sense for a vertical because that's when I'm moving up and down. Your co-vertices then for a horizontal is when I'm moving up and down, and left and right for a vertical ellipse. Left and right. And then your foci are always on your major axis, which is on the same axis as the vertices. And then also really important to talk about is how you find your foci is you do c squared equals a squared minus b squared, which is derived from the Pythagorean theorem, okay? Notice if we have equations, you might see minus h or minus k there, and what that tells you is that the center is not on the origin. So if h and k is 0, comma 0, that's why it's going to be written like this, x squared over a squared plus y squared over b squared. If you have parentheses, like in these visual examples down here, then your center is not on the origin, it is on another point on your plane. And so these are the key features of ellipses, and we're going to go through some examples of them. And here is our first example. Let's talk about it. What is the equation in standard form of an ellipse centered at the origin with a vertex of -6, 0 and a covertex 0, 3? So right away, if I know my origin, my center is at the origin, I know it's going to just be x squared over something and y squared over something. I don't have an h and k. The h and k is 0, 0. And then I know it has to equal 1. And now when they tell me my vertex is at -6, 0, I mean, you can even start to visualize this, and I always like to do a visual here. If I have vertices, 3, 4, 5, 6, and then a covertex at 3, I know right away this is a horizontal ellipse, and I also know then my a squared is first here. Because the a squared is always the largest, and if the a squared is first, I have a horizontal ellipse. And so if I know my vertex is at -6, that's my a value. And my covertex is the b, and that's at 3. And you can have it, it's always plus or minus 6, so you can have it plus or minus these numbers, as you can see up here in our chart. And so then I know that a squared is going to be 36, and b squared is going to be 9. And that is going to be the equation of our ellipse using the vertex that they gave us and the covertex. In example 2, it says using c squared equals a squared minus b squared, which is how we find the foci. What are the foci of the ellipse with this equation? So notice in our equations, it has to be set equal to 1. So that's going to be my very first step, is rewrite this equation but have it set equal to 1. And how we're going to set it equal to 1 is we're going to divide both sides by this 225. Because I know 225 divided by 225 is going to give me 1. And then I've got these fractions to reduce. 25 over 225 is 1/9. So I have x squared over 9. And then 9 over 225 is 1/25. So I'll have y squared over 25. And so here's our equation, which is really helpful, because then that tells me here's my a squared, because the a squared is always the largest number, and then here's my b squared. So I have a squared equals 25. Then I can write down my a is 5, my b squared is 9, so then I know my b is 3. And then in order to find the foci, I have to do c squared equals a squared minus b squared. So I'm going to get 25 minus 9. And so then I know c squared equals 16. Take the square root of both sides, I get c is 4. And so my foci are at 0, 4 and 0, -4. And that's really important, and you can see I was hesitated to think about that, is we need to think about whether our foci, and I'm going to come back up here to this chart, is c, 0 or 0, c. And it matters whether this is a horizontal or vertical ellipse. And so right away, when I realized my a was second, that was the bigger number, I knew this was going to be a vertical ellipse. And if it was a vertical ellipse, then I know the foci had to be on the major axis, which is on with a y value. So my foci are at 0, 4 and 0, -4. So my next example, let's have us practice writing the standard form of the ellipse that is shown in this picture. Let's zoom in a little bit here. And so some key information that I have to point out is the center. So my center is at 0, 0, which tells me that I'm going to have x squared over something plus y squared over something equals 1. And then I need to find out what the a squared is. Well, let's see. My a is on my major axis. This is my a. 1, 2, 3, 4, 5, 6, 7, 8 is my a. So I know a squared is 64. And then my b is the distance to the co-vertex. And so that's 1, 2, 3, 4, 5 is my b. So I know b squared equals 25. This is a horizontal ellipse. And so horizontal ellipse means that a squared is first. So I'm going to have 64 and then 25 over here. And that's my equation of the ellipse. So remember that a is the distance from the center to the vertex is a. And then the distance from the center to the co-vertex is b. And the vertex is on your major axis and your co-vertex is on your minor axis. So it just helps to kind of label that the first couple times, and then you'll definitely get used to it. So then example 4, we are going to now practice graphing. Some key information that we can point out from the equation is my center. Right away, I notice it's not on the origin, right? I have that 2 there, that plus 2 I see, and that minus 1 I see. And that tells me my center is at -2, 1. Remember that formula is originally x minus h squared. So in order to get a positive 2, it would have to be x minus a -2. And so that's how I know -2 is my h value. Then let's check out, I know my a squared is the bigger denominator, so that's 9, which is going to tell me a equals 3. B squared is 4, which is going to tell me my b is 2. And I also need to find the foci when I graph it. So all of your graphs need to also include foci points. And we get foci by doing c squared equals a squared minus b squared, which is going to be 9 minus 4, which is going to be 5. So c equals the square root of 5, which, guys, is about 2.23. And so this is some good key information that I need to graph the ellipse. So I can start with the center at -2, 1. And then I know, because that a squared was second, I know this is going to be a vertical ellipse. So my major axis is vertical. So my a, 3, that is the distance from the center to the vertex. And I'm going to go up 3 units. Then I'm going to go down 3 units. And then my b is the distance from the center to the co-vertex. So I'm going to go left 2 and then right 2. And so here I pretty much have my ellipse. And then the last thing I need to draw is my foci, which is 2.23 units from my center. So here's a foci, and here's a foci. And I need to include the foci in my graph of the ellipse. We have 2 more examples here. Let's graph another one. So as soon as I look at this equation, I realize it's not in standard form. I need it to be set equal to 1. So I'm going to divide both sides by 144, which gives me an equation set equal to 1. Then I'm going to reduce these fractions. 9 over 144 is going to be 1/16. So I have x squared over 16 plus 16 over 144 is 1/9. So I have y squared over 9. And so now, as soon as I look at this equation, I can pull out some information. My center is at the origin, 0, 0. I see my a squared is first, which tells me my a is 4. And then that also tells me this is a horizontal ellipse. And then my b squared is 9, so my b is 3. And then I can find the foci by doing c squared equals a squared minus b squared. And I get c equals the square root of 7, which is about 2.65. And now we're going to start to plot this. We'll start at the center. My A is 4, so that's the distance from the center to a vertex. It's a horizontal ellipse, so I know my major axis goes horizontally. So I go to 4 and -4. That's my vertices. My co-vertices are going up and down. And then my foci is on my major axis, which is the horizontal axis here, and it's 2.65 units from my center. And so here is my ellipse for this equation. And now let's do one last one here. And it is going to ask us to write the equation in standard form. So in order to do this, this requires us to complete the square, which is a skill that we don't use often, but we do have to keep in our toolbox and refresh our memory sometimes. Okay, so when we complete the square, the very first step is to move the constant term to the other side of the equation. So here is that +1, we're going to move it to the other side of the equation. And when I do that, I'm going to start to write my like terms next to each other. So I'm going to go 4x squared minus 8x plus y squared minus 2y equals -1. So notice I started to write my x's next to each other and then my y's next to each other. In order to complete the square, the a needs to be 1. So that's going to be my next step, is to factor out this 4 here because that's an issue. And I'm going to leave a little space there. And then I'm going to go y squared minus 2y, leave a little space, equals -1. And so if you remember, in order to complete the square, we add this constant value to two terms in order to create a perfect square trinomial. That term is b over 2 squared. So I'm going to take my b value, which is right here, -2. I'm going to do -2 divided by 2 and square it. That gives me -1 squared, which is going to give me a +1. That's the constant term I'm going to add to that to create this perfect square trinomial. Remember, what I do to one side, I do to the other. So notice if I add a 1 here, which is technically being multiplied by 4, so really that represents a 4 on this left-hand side of the equation. I have to add a 4 onto the other side of the equation. And then I'm going to do the same thing with the y's here. My b term is -2 divided by 2 squared, and I know I'm going to get a +1. So if I add a 1 here, and that really is a 1, I'm going to add the 1 to the other side. And so now we can start to write, we could factor. So I'm going to have 4, and now if I factor this, I get x minus 1 squared plus y minus 1 squared equals -1 plus 4 plus 1 is going to give me 4. And then my very last step, in order to write in standard form, is I know the equation has to equal 1. So I'm going to divide everything by 4 to make it equal 1. These 4's cancel out, so I'm left with x minus 1 squared plus y minus 1 squared divided by 4 equals 1. And that's the standard form of that equation. So again, you can tell some important information about it. You can tell that where the center is, you can tell what the a is, the b is, and you'll be able to find the foci when it's in the standard form. We like it a lot better than this form. Okay, so this is your lesson on the conic section of the ellipse. If you have any questions, please send them my way. Great job, guys.